You can see the fill time, then you can see the plastic flow. All right, you can also preview that. Then here we have the confidence of fill, then the quality prediction. Here is the injection pressure. This one is the pressure drop. This one is the temperature at flow front, and orientation at skin, then the average temperature, the time to reach ejection temperature, the frozen layer percentage, the air traps, the wheeled lines, as well as the groove from. Alright, so that's just about all for the analysis results. Okay, so this is the interface for the Moldflow Advisor 2023. Now I want to create a new project, and of course the location is just where the AMA. If it is AMI, that's the inside, but if it is A, that's the advisor. So now I'm just going to create quick start. Quick start, yes. Alright, so this is quick start. Now I'm going to go ahead again and import my part file. Let me choose this. Alright, let's just choose this. Alright, now having chosen this, you discover that the recently imported models has been highlighted and listed, okay, as well as the location of the model. Now all you need to do now is click next. Alright, then click next and wait for the model to load. Now let me just go back and let's preview the process. First of all, we checked the location and I selected the mouse cover field study file. Now it comes on as a list in the recently imported models. Then you click on next. For the model to process the import part. Alright, you can see it there. Now it says select the appropriate unit. So whatever unit you're using in your simulation drafts, you can select here. Then you also have appropriate dimensions. If the dimensions differs, all you need to do is make the necessary adjustment here, all right, based on what you have in your draft. Then we click on next. Once you're satisfied with that, you see, as soon as you click on next, you see that it is now displayed behind the scene. So alternatively, you can check this, check suitability, but I'm not going to do that for now. Then you click on next. The import wizard is still processing. All right, now in this place you see that you have the import wizard processing, no errors determined on model import. All right, now standard, you have this analysis type is very important. You can decide to choose the advanced or the standard. Now for the thin part, if your model is a thin part, it doesn't contain much of solid parts like a thickness, it has thin edges, I will always recommend you go for the dual domain. All right, but if on the other hand it has parts that are thick, I'll be running some analysis on that too very soon. I'll be sharing with you guys. So you go with that 3D. That's when you go for the 3D. There's like the blocks, those mechanical blocks. The 3D will be very, very good for that. And some of the electrical parts as well. Now here, another important thing I want to bring your attention to is that you click on the show log. All right, it's an option. All right, after you've done all this, just click it so that when the machine analysis is being run, it will be displayed. All right, so having done all this, we'll say finish. All right, so as you can see, the menus for the Moldflow advisor is just similar to the one of the insight and the synergy, because there are 3 variations. The only difference between this one is that besides every other thing that you already know, is that it has an advisor tab, and this advisor tab gives you an edge of actually determining the level of the cost, the pricing of your the cost implication of your simulation. So when you are producing your parts into a physical product, it will give you a rough estimate of international price, in US dollars for the analysis that you're running. So right now what I'm going to do is I think coming to this view, you can see that of course we have several ways in which you can manipulate your screen and all that, but where I want to bring you to is the orbit, which you can actually use to, of course, as usual, tweak and see some of the parts, to know exactly what it is. All right, and what your path file looks like, in a flipped dimension. So what I'm just going to do now is that we're going to quickly run the analysis, and usually when you run the analysis, it will do a meshing, and then the analysis sequence will follow. So let's quickly analyze. There was output there, and it was saying it's actually requesting for the internet, but the internet is an optional thing when you're running your analysis. There are 2 ways in which you can actually connect to run your analysis. One on the local space, which is your computer without internet connectivity or cloud use. All right, then the other one is through tokens. I think the minimum token they sell for is about $1,500 US dollars. But you may not need that, really. You really may not need that. And what is most needed, what is most interestingly necessary, is for you to locally run your analysis. Once you have the system specifications that match up with the analysis and the sequencing, then you can complete your simulation and know what kind of results the product will be in real time. Now if you look at this page, you can see analysis checking is scheduled. Analysis checking is scheduled. So all you need to do at this moment is you wait for that process to be complete. Don't forget, this is Moldflow Advisor, all right, 2023. Last year the NEDI staff were introduced to the Moldflow signage in 2024. They are both the same. The insight gives insight into maybe certain features of your part. All right, the Synergy is more like the difference between the Synergy and the Advisor is that the Synergy doesn't give you the cost implication, while the Advisor does give you the cost implication. So let's now go ahead and make the analysis. So you can see that the analysis scheduling has been transformed into the analysis running. The meshing actually takes place before the analysis proper, all right, and that's something that we need to be aware of. You can see that in the lower pane there, the meshing percentage for the meshing is being red. And let me also confess, or rather say here that make sure you have internet connectivity, because sometimes the simulation compute manager might need to, in fact will even need to verify internet connectivity in order to verify a background license for running the software. Alright, so the meshing is done now. The analysis is about to kick off. Yeah, you can see that now the analysis checking is scheduled, and the results, in this pane, this study pane there, you're going to be seeing a list of items that will be displayed. So now the filling, you can see the 0% filling is taking place. Now it's waiting for the license availability. The licensing is a very integral part of this software, and if the licensing is not right, the analysis might not run. Okay, so you can see now that the analysis has commenced. Once the licensing has been verified, and for those that participated at the last workshop, NEDI, Nasenin NEDI workshop, I've actually spoken to one of your administrators, and it's most likely I'll be coming down there to help configure the licensing for the Moldflow. Now I must also state here that there are specific or there are 3-tiered versions of the Moldflow. You have the Advisor, like I said previously. You have the Advisor, you have the the insight, and then you have the synergy. All of them just have slight differences, but they are all overall the same. The most unique thing that marks out the advisor from the other two editions is the ability to get cost estimate, part of which I'll be describing before the end of this video. So there you can see the fill time, the plastic flow, the confidence of fill, quality prediction, the injection pressure drop, and time to reach injection. So now, all right, now you can see on the screen the mouse cover fill study is complete, the analysis is complete. I'm going to run through some of the functions, or the component functions of this particular part model. All right, this is the fill time. All right, this is the fill time. You can see the fill time there, and just animating this fill gives you overview of what these parameters indicate. You can see the fill time, then you can see the plastic flow. All right, you can also preview that. Then here we have the confidence of fill, then the quality prediction. Here is the injection pressure. This one is the pressure drop. This one is the temperature at flow front, and orientation at skin, then the average temperature, the time to reach ejection temperature, the frozen layer percentage, the air traps, the wheeled lines, as well as the glue from. Alright, so that's just about all for the analysis results. Okay, so now let's look at the cost advisor. This is something new that I want to discuss about briefly. Now, when you click on the cost advisor, it says that the cost advisor allows you to estimate the total production cost per part. The advisor needs to be set up only once. It will track changes to the model and processing conditions. The advisor updates reports to display the current cost based on material usage, the volume of the runner system and cavities, as well as the operating costs. So we click on next. It says the cost advisor has analyzed your model layout and determined the following volumes for the cavities and runner system. Alright, so we are setting the cavity volume to 13.089 centimeter cubic centimeter. Now, in order to calculate the material cost, please specify how many shots you wish to produce and the price of the material. Shots I get should be in the units. Let me assume, let's just put this at 500. Material cost, let's put this at maybe 100 per 1 kg. Yes. Then total material required, this material cost short. Alright, material per cost short, then material cost for total production. You see, so based on all these computations or parameters, variables, you can see that the production, you have a production tab here. It says total shots to be produced, the material, this is generic PP, generic reports, material cost, I place it at $100 per 1 kg. This is just to test run how to do this, all right, to go about this. Then you have total material required as 5.85 kg. Then you have material cost per shot at 0. Then material cost for total production $585.19. $19. You can see that there. So this is like the active summary. Now for this, you can see the running costs. Let me just flip back. Alright, so now this is mode costs. Let's look at this mode cost. The cost advisor can take into consideration your mode price. Please enter your mode price, maintenance cost, and the total mode life cycle. Now for this again, let me just enter 500. Oh no, let's just enter the 200 there. Then the total shots, I can put this at 500. Then material cost, let's just put this at 100 per 1 shot. Total required, okay, let me see, let me put this at 50. Alright, you can see the moment I put the maintenance cost per shot, the mode cost for total production increases. Now this is another molding cost. The other one, the first one was material usage. All right, you have the mold usage, you have the material costs, material usage, then you have the mold costs. Then following that, you also have the molding cost. So for this, let me put just say 500 per, say 100. Then here's machine costs. Let me just put that at 150. 100 downtime. Let's assuming we put a downtime of just 5%. So you have molding cost per shots, molding cost for total production. Now, you can as well alternatively put this, depending on what exactly you are looking at. Now, all right. Now, post molding costs. It says the cost advisor can also take into consideration your post molding costs. Please enter any relevant cost per shot here, or press finish to complete the cost advisor wizard. So you have finishing. Finishing, you can put let me just say 50 per 10. I want to put something uniform here. 50 per 10, 50 per 10.
Audio Jungle. Audio Jungle. Audio Jungle. Audio Jungle.
Let's now look at how we're going to install Autodesk Moldflow Advisor 2024 version. So we agree to the terms of use. And then this location, of course, is very important for you to take note of, except if you have an alternative path for the installation. So we click on next. Now this is the major thing it's going to install, the Autodesk Moldflow Advisor 2024. An additional component is the Moldflow Communicator 2024. So with that settled, we just click on install. So that marks the installation process. The next important thing is for us to go into this folder, the x86 or 66 folder, 64 rather. Now in this folder you see a lot of things here. One of the things that comes to mind is the NNHelm. That's the Network License Manager. So simply right click and open to install. Alright, so this is it. This is the Autodesk Network License Manager setup wizard. Alright, so usually of course you make sure you agree to the terms, then you click on next. Now this location, it is a default location by the way, so instead of leaving it here, alright, I would rather prefer to locate it in the shared folder. That's just watch the screen. You come to C, then you come to program files, then you come to common files, Autodesk shared. Create a folder here and call it this, give it this name, then enter into the folder and make it the default installation folder. Why I put this here is because this place makes it easily accessible for licensing issues, you know, and common shared files and all that relates to Autodesk. So we simply click on next and then we're set to install. So that marks the end of the installation, and once that is installed, this is the next important thing: configuring the license manager tools. And we're going to do that in a brief way. Okay, so here is asking us, would you like to import your user options for Moldflow Advisor 2023? Well, you could. If you have an existing setting or preference, then you can say yes. Otherwise, you say no. But the default says yes. The previous version on this system. So what I'm going to do is that I'm just going to click yes. Okay, so right here is asking us for the license. Now, usually you select on the use network license. Of course, there are three options here. There is single license server, there is redundant, there is distributed. So we're going to choose the single.
Audio Jungle. Audio Jungle. Audio Jungle.
So as you can see, this is the previous settings or projects that was used. So I'm just going to open one of them. All right, and you can see that the menus are partly still frozen out because we have not yet opened the specific task under the project. You can see there's really little to operate on here, all because they are grayed out, or because a specific task under the project has not been activated. So in order to activate it, all I have to do is just double click on this project, and then it displays in another tab, just an adjacent tab to the existing tab that holds the object linking and embedding. All right, so this is it. This was the last analysis I did on this mouse cover. All right, this is a computer mouse cover. As you know, computer mouse objects are usually made of plastics. So then if you look up here now, you see that the menus have now been fully activated. The tools, the home, the view, the geometry, the boundary conditions, the results, the reports, start and learn, the community respectively. All right, so this is just how 2024. Now 2024 seems not to be too different from the 2023 version. They have a very close similarity. There's something you need to know about these softwares. The more they are updated, the better they become, and the further away or further apart they are from certain features. Some other features will be dropped while others will be improved upon. All right, now you can see in this results tab as well, you can see the cost advisor. But before I go there, I want to quickly go over this results that I did under the 2023 version. You can see the fill time. All right, let me just zoom this out a bit. Then of course, now before I go on, you can see beside here now there is this object linking and embedding, besides this one that actually browses to the online website. Okay, that's what this one does. While this is a help menu here. As you can see fill time results, and it also gives a sort of explanation about each of these results time, or these results properties, right? The properties of the object, this fill time and the likes. Like here now, you can see a very helpful tab. This is Moldflow. It says the flow pattern is balanced in a path with good fill time results. All right, you can read this through and get to understand what each of these analysis results does. Now we have the plastic flow, then we have the confidence of fill. As you are clicking on this left hand pane, you are getting the explanation for each of these things. All right, what each of them stands for, and I think you have to be connected in order to be able to get this kind of things. Then you have the quality prediction. You can see there the quality prediction result is used to estimate the quality of the mechanical properties and the appearance of the parts. This result is derived from pressure, temperature, and other results. It's a very useful help menu that has been introduced in the 2024 version. So having it really makes things pretty much easier. Then you have the injection pressure. The injection pressure results at the end of fill. So the injection pressure result, which is produced by fill analysis, shows the maximum injection pressure value obtained before velocity pressure switch over occurs during the filling phase. The pressure at end of fill result, which is produced by a fill analysis, shows the pressure distribution in the cavity at the instant when the cavity is completely filled with polymer. At the beginning of filling, pressure is 0 or 1 atmospheric pressure unit in absolute pressure scale. So you can just read more about this results property or function, all right, of this object, because each object has different object results. So like the fill time for a rectangular or a block object is different from this object, the properties. All right, all is just take this as properties. Properties is usually a description of an object. All right, describes an object. So just understand that that concept of object properties and methods. Now let's look at the pressure drop here. You can see here pressure drop results. Pressure drop results uses a range of colors to indicate the region of the highest pressure drop through to the region of the lowest pressure drop. This result indicates how much pressure necessary is to fill the different areas of the part, as shown in the following diagram. So they made a typical diagram here of what we're talking about. Now, also they have here, using the results, things to look out for: increase the maximum injection pressure to improve the confidence of fill. Move the polymer injection location closer to the problem area after the part geometry. All right, so let's look at some other ones now. You see the temperature at flow front. This one also gives us a brief explanation of the temperature at flow front. It says that the temperature at flow front result, which is produced by fill analysis, shows the temperature of polymer when flow from flow reaches a specified point in the center of the plastic cross section, as shown in the following diagram. The temperature at flow front result uses a range of colors to indicate the region of interest temperature in blue. All right, so these colors are actually specific to different. They are indicators for sure. They're just indicators that you need to know where the heat is appropriate or it is not appropriate. And let's look at the orientation of skin. It says the orientation of skin results provides good indication of how molecules will be oriented in the outside of the part, showing the average principal alignment direction for the whole local area at the end of filling. All right, you can read more of that there. All right, there are also typical examples given there. Then you have the average temperature here. You can see that the average temperature shows the average bulk temperature through the thickness of parts at the end of fill. The temperature of polymer melt changes not only with time and location, but also with thickness during the entire injection molding cycle. Then here you have time to reach the injection temperature. It's one of the most important parts. So the time to reach the injection temperature result shows the amount of time required to reach the injection temperature, which is measured from start of fill. Then here we have the frozen layer percentage, and we have the air traps. All right, then you have the wheel lines. Wheel lines result displays the angle of convergence as two flow fronts meet. The presence of wheeled lines may indicate a structural weakness and or a surface blemish. Tip: by overlaying the fill time result and stepping through the animation, you can see how the flow fronts converge. So let's try that now. So you can see now, just playing back the animation, it's like giving you how the fronts converge, just like what we did earlier in the actual field animation. Then let's look at the grow from. Now, according to the documentation, it says the grow from results is produced by field analysis, shows the areas that are filled from each gate in multi-gated parts, so that you can determine whether the flow within the part is balanced. A grow from result that shows uniform filling will be balanced. A grow from result that shows the different gates are trying to fill the same section of the part will be unbalanced. Okay, non-uniform filling left and uniform filling right are shown in the following diagrams. Now, overall, you can see that there is a big improvement in the 2024 version, especially with this help, online help tab that you can easily expand. So you can expand it to see more of it, and you can also reduce it to its normal position so that you can see your object allowance very well. Now, let me quickly go into this cost advisor. Now, the cost advisor allows you to estimate the total production costs per part. And this is very important. The advisor really needs to be up only once. It will track changes to the model and processing conditions. The advisor updates reports to display the current cost based on mutual usage, the volume of runner system and cavities, and operating costs and overheads. Alright, so the first thing we're having is the mold usage. The cost advisor has analyzed your mold layout and determined the following volumes for the cavities and runner system. You can see the modified calculation values. You can actually, this is in cubic centimeter, modified calculated values. Now, the next one is the material cost. All right, it says in order to calculate material costs, please specify how many shorts you wish to produce and the price of your material. All right, so I initially entered this. I entered 500 units for shorts. Then the generic PP, of course, you can. I just left this as it is. It's the default value. The material cost, I placed $100 per 1 kg. That's what I imputed here. Then the total required, I imputed 5.85 kg. Then the material cost per short, I put that at 1.17. So the material cost for total production is $585.19 US. So click on next. Now here we have the material usage. This say your production will also be affected by scrap. If you know your historical scrap output percentage, or can estimate, please enter it here or skip to the next step. So we have scrap rates, estimated scrap rates 0.00, then maximum regrind allowance. I just put this. Now let me just assume that, let's adjust this to 5, all right, and place this at perhaps 10. So the range is between 5% and 10. So estimated material cost including scrap and regrind. This is the tab. This particular box is for this estimated cost for including scrap and regrind. So we said the estimated production including scrap, I place it as 526. The total material requested 6.16 kg. The material cost per short, I put that at 1.23. So the material cost for total production is this with respect to the usage, all right, taking the scrap rate and the maximum regrind allowance into consideration as variables for this. Then here we have mold costs. The cost advisor can also take into consideration your mold price. Please enter your mold price, maintenance cost, and total mold cycle, life cycle. All right. So now for the mold cost, I entered for the mold construction cost, I entered 200. Then total shots per mold life cycle, I entered 500. The maintenance cost $100 per 50 shots. All right. So I now put this as total molds required as true. Okay, so let me just make this adjustment here. Maybe we put 20 molds, 20. No, let's leave that as it is. So the mold cost for total production is $2,400 based on the previous variables. All right, like the mold cost, construction cost, the total shots for mold life cycle, the maintenance costs, estimated mold cost, total molds required, mold cost per shot, mold cost for total production. Now we move to the molding cost. Since the cost advisor can also count your running cost for your injection molding machine and can take into consideration your historical downtime. Then you have molding costs. Override calculated cycle time. You have cycle time as 9.47. Then the running cost, you have it per shot. The machine cost is per hours. The downtime, I place this as variable of just 5%. All right. Now estimated molding costs. Molding cost per shot, I put that at 5.41. The molding cost for total production as 284 or $2,847.93. Now for this section, I put for this section we put the post molding cost. The cost advisor can also take into consideration your post molding costs. Please enter any relevant cost per shot here or press finish to complete the cost advisor wizard. So this is the post molding cost. You see the finishing 50% shots, assembly 50% shots. I just placed a uniform value into all these columns. All right, these rows: the finishing, the assembly, secondary operations, packaging, shipping, overhead, order. All right, then here we have estimated post molding costs. We have post molding cost per shot as 35. Then post molding cost for total production 17 at this is $17,500. So having done all this, you now click on finish. You can see the costs, you see, as described from section to section: the total cost, material costs, the total mold cost, the total machine usage cost, the total post-molding costs, the material cost per shot, mold cost per shot, molding cost per shot, post-molding cost per shot. Then the material cost, total shots to be produced, 500, scrap rate, estimated production including scrap, cavity volume, maximum regrind allowance, total material required. Then material costs for total production, the material cost per shot, use material cost per shot, then the mold construction costs, total shots for mold cycle. Now you can see here that various sections of this production process has its own variable cost, total cost, material cost, mold cost, molding cost, the post molding cost, and the cost breakdown. You can see that in the pie chart. So the material, the mold, the molding, the post mold. All right, this is just a typical example. All right, it's not exactly precise, just to demonstrate to you how to use this costing menu under the Autodesk Moldflow Advisor 2024. All right, so these are things that are actually very useful. Now you can also plot. There is a menu for plotting properties and the methods. You have animation. You can set the variables that you need to tweak the animation process. So that's just all about the Moldflow Advisor 2024/2023 or 2023/2024 respectively.